Hello everyone, my name is Francois Rheault. I'm a postdoctoral fellow at Vanderbilt University, and today I will present the TRX, a community-oriented file format for the BID standard. This will be a fairly non-technical talk organized as follows. First, I will give you a bit of background information about tractography and existing file formats. Then I will present what we are proposing as a standardized file format, followed by what has been done and what have to be done. And then I will conclude with a summary and take-home message for the project. If you're interested, you can visit the GitHub page and get more detail if you want. Let's start with some context for you to understand the project. First, for those of you that are not familiar with tractography, tractography is a virtual 3D reconstruction of white matter pathway connecting different regions of the brain. It aims to represent how the white matter is organized and wired. Tractography generates millions of lines, called streamlines, and when the whole brain is reconstructed with millions of streamlines, we call that a tractogram. The way this is saved is in the form of an explicit representation where each 3D point is saved, often using floating point precision. So 3D coordinate for each of the unobserved point per line, for each of the millions of streamlines. This leads to file the size of gigabytes per subject, and it is common that the largest file in a tractography pipeline is the tractogram, or even any neuroimaging pipeline. Some compression algorithms exist, but they are rarely used. And lossless compression does not reduce the file size that much, and lossy compression comes with downsides. This leads to challenge in loading speed and saving speed. Post-processing of tractogram require a lot of memory, and each complete or partial copy of the tractogram during post-processing quickly occupy a lot of hard drive space. This led many software to create their own file format to solve these challenges. Current tractography file format obviously works, but they are not all the same. Each file format comes with their pros and cons, and they are not all supported by every tool. This leads to each tool, labs, and sometimes even projects to pick their favorite file format or even create their own, and often stick with it. This is perfectly fine by itself, but it can impede data sharing or cause compatibility issues. I don't want to list all of the existing file format for tractography, but there are two main categories. There are the specialist file format, which are custom made for specific application and performs really well in planned scenario. They are a bit harder to support sometimes due to their customization, and their features were tailored to solve specific limitation. Then they are generalist file format. They were designed to cover a wide range of scenario and accommodate most researchers. They are often easier to support, but when specific technical requirements arise, they often fail to perform. The features were designed to let users decide how to use them. This is why a single file format cannot do everything. This is not abnormal, it is expected. Second, let's talk about BIDS, which stands for Brain Imaging Data Structure. BIDS is an international effort aiming to reach an agreement between researchers on data organization. This project attempts to facilitate data sharing between labs, and obviously there is no one-size-fits-all convention, so each modality in each field has its own specification within BIDS. At the moment, there is no specification for connectivity, so functional and structural connectivity matrices are not part of the standard, and derivative file for fusion MRI and tractography pipelines are not part of it. More importantly, each type of file has an agreed-upon file format inside of this. So for example, volume have NIFTs, surfaces have GIFT, metadata and tabular data have JSON and TSV, but tractography does not have one of its own file format and cannot be represented using one or the other I just mentioned. So when it was time to talk about a community file format, that would be the official file format for tractography in the BID standard, it generated a lot of discussion. From a small comment on a GitHub thread, it led to tens or hundreds of comments by a lot of software developer and user in the community. We quickly converged toward the idea of creating a new file format that would combine the existing feature of TCK and TRK, the two most popular file formats at the moment. But most importantly, it was very important that the file format would be conceptually simpler, more efficient in terms of speed and space, easy to support, and would not require complex dependencies. It was a really hard exercise at first because everyone had their specific needs. And while some people would say, I don't need feature X, others would say that feature X was crucial. So this was an exercise of compromise and discussion. So this discussion led to our proposal, the TRX. Since the goal of this file format was the inclusion in the bid standard, it was important to at least allow the new file format, the TRX, to do as much as the TCK and TRK. The idea was that by making sure that TRX could do at least as much as the two most popular file format, the transition would be easier and people could easily convert from one to the other. By harmonizing feature into a single file format and making sure that conversion tool would be standardized, it would make data sharing a lot easier. Having a common file format also means smaller software and toolbox could load and save a single file format instead of supporting a few, which save a lot of time and reduce risk for errors. This will boost compatibility across toolboxes on the long term. Also, the TRX file format allows for more freedom in terms of data type and data organization, which could increase computational and storage efficiency. This would be a generalist file format. So the goal for it would be to be useful at least to 70 to 80% of researchers, not necessarily everyone all the time. So now let's be a bit more specific. You can see here how the TRX file is organized. The file structure is the most important part of it because the TRX is itself simply a folder or a zip file, compressed or not. The filing convention informs how the data is organized and how it should be read. So just remember also, this is not the final specification. This is still work in progress. First, you can see here header.json. This contains classic information about spatial transformation, number of streamline, number of vertices, possibly more reserve or optional tag. Then you can see the file position right here, position.3.1216. This contains the data describing the coordinate of all the streamline of the tractogram. The 3 means it's three-dimensional, and the full 16 is the data type. This can be read a lot faster than other files because it allows reading the data as a block. And here you can see offset.un64, which contains the starting position of each streamline. So you can read the block of data I just described streamline-wise and allow for memory access in random order. This is similar to the new VTK version 5 file format, which came with the new VTK recently. You can also see folders. So you can see folder here containing different kind of metadata. So DPV and DPS are the easiest to understand. Data per streamline and data per vertex, in which you can store scalar or vector for each streamline or point, which is similar to what exists in the TRK file format. Then there are groups and data per group. This is a new concept that allows you to store sparse indices from the tractogram. This can be used to store bundle segmentation information or custom filtering indices. This is a new feature that is not in the TRK or the TCK. And just to reiterate, the file structure can be in a folder or simply a zip file, compressed or not. And this simple design is self-explanatory, user-readable. It's easy to support and to extend. And it allows user and developer to customize what they save in the file format for the future processing or data sharing. But that's the proposal. But what have been done more concretely about it? Like I mentioned earlier, there was a lot of discussion, a lot of threads on GitHub about what should be the minimal dependency, which version of C++ or Python should be supported in the proof of concept, default data type, compression. A lot of people were contributing to these discussions. Just to give you an example, when I was ready to submit this OHBM abstract, I showed the text to the collaborator and I got hundreds of comments overnight. So people are really participating to this effort. More concretely, we have a timeline here, and the big discussion at the phase at the beginning took a bit more time, but now we are starting to go a bit faster. Now we have a proof of concept implementation in Python, JavaScript, and C++. We have script and utilities and the benchmarking set up. We are currently working on unit tests and making sure it's compatible on multiple OS. In the current year, we are planning on having a fork of MR-Trix or maybe even the MyBrain visualization software to use a C++ implementation to allow people to use it and maybe find some bug or find some limitation that we want to be aware of. Then we will be working on incorporation into NiBabel in Python. And then we'll put out a candidate proposal for the community to review next year. And then at some point next year, we hope that we will have various conversion scripts in multiple toolboxes. So people can transfer easily from multiple file format to this one. And then once we got the feedback from the community review, we will put forward a final proposal for the specification and hopefully have the file format included as part of the bid standard in 2024. So this is what you had to know about the TRX file format initiative that we put forward in the past year. Now time for some take-home message. Remember that when researchers have difficulty with data sharing and data reuse is impeded, this is considered a missing opportunity to do science. To solve this problem, we are proposing a community-driven bid standard for connectivity, and more specifically, we are proposing a next-generation file format for tractography in the bid standard. Many contributors are already helping and keep on giving of their own time to help us, covering a wide range of tool, library, and language. If you're interested in technical contribution to help with the code review, port to NIBabel or DiPy, implementation in other language like MATLAB or Rust, your help would be welcome. And if you want to add support for the TRX file format in your own tools, you would be welcome and we could help you with that. If that's the case, you should look at the GitHub repository. If you have any question about the file format, the process to get there, technical question about the benchmarking, I would be happy to give more detail at the poster. Finally, a huge thank you to all the collaborators from all over the world. This is a community effort and it would not be possible without a lot of help from everyone. Thank you very much and I hope you enjoy.